Hey everyone, I've got a few questions for you today to kick things off. And let's assume that you've got an application or a set of applications, and let's assume that they're hosted up in Microsoft Azure. Now, they don't have to be for this service, but for now, let's assume that they are. My question to you is, do you know how many users your application or set of applications can support? If someone like a product manager or a business owner, or someone who has a stake in being able to make sure that the application is always online and scalable, if they came to you and said, hey, next week we're going to have 5,000 users come on and they're going to ramp up slowly and they're going to use the product for the rest of the week and then they're going to drop off, would you be confident in saying that your application can scale okay? And do you know if it can handle with sharp increases of users or slow increases over time of users coming onto the platform? You might be sitting there saying, yeah, that's all good. I've implemented autoscale across all the components. That'll work out just fine. But have you actually tested that autoscale is working properly across all of the different components of your application? And do you know that the scaling settings are set correctly for how that usage is going to ramp up as well? Do you know where the bottlenecks are in your application? Maybe your database is working well, but maybe you've got a caching system that becomes the bottleneck and you haven't quite figured that out yet. Or maybe you've got an application and you bring in a new component, like Redis Cache, for example, and without realizing it, maybe you've put that in at a SKU level that is going to cause a bottleneck across the rest of your application. So that is where today's topic of Azure Load Testing comes in, where we can test the applications using kind of a software as a service load balancing service that Microsoft provide through Azure Load Testing, and that is what I want to show you today. I want to start here by kicking things off in a whiteboard where we'll go through an overview of what the service is and kind of at a high level how it hangs together. And then I've got a bunch of demos lined up that we'll jump into. I've got a slide that'll talk through what the demos are and what I'm going to show you. So let's start now here with the overview. So what actually is Azure Load Test? Well, for starters, it is a stock standard resource that we can spin up inside of Azure. So this here is kind of like a container, and this is Azure Load Test. So you can spin up one or more of these, and there might be a good reason to spin up more than one, and I'll explain that as we go through it. Now, inside of Azure Load Test, you can do different things. So this is kind of the container resource, and then within it, we have different configurations for spinning up our tests. And everything inside of Azure Load Testing is built around the notion of these test scripts here, which are JMeter. So JMeter is a product by Apache, and it is an open source Java application, and it is designed specifically to test functional behavior of an application and also to test the load of an application as well. So instead of creating some proprietary service here, Microsoft are leveraging JMeter here to run all of the actual load testing itself. So when it comes down to it, most of your time will probably be spent inside of JMeter and getting the scripts and configurations inside of that correct for your application. Because not every application is just going to scale by doing, 1,000 GET requests over the course of an hour or something like that. Most applications are going to have a single login process and then maybe simulating a user browsing around the application, maybe doing a checkout or a purchase or some sort of action like that. It's not simply just going to be a bunch of GET requests. There are going to be different requests. Maybe they'll go and delete some things from the system, so on and so forth. So I think you'll end up spending most of your time, if you start getting into this, in the JMeter configuration. And there are a bunch of resources around on the internet for free, a heap of stuff on YouTube, a heap of great docs out there for getting into JMeter itself. I'll show you a few basic ones here today, but we won't be getting too detailed overall. Now, the next thing is that inside of the load test service, we actually need to create a test itself. And then inside of that test, we have different properties. So in here, we say how much load do we actually want to put against our application. Now, inside of the JMeter script, we can specify how many threads or virtual users. And the recommendation there is to have no more than 250. And this is a Microsoft recommendation for the Azure Load Test service. You can scale it up past 250, and I'll explain how you do that with the test engines in a moment. So when you create a test, you actually specify which JMeter file you want to use. So that is a component of a test. We specify how much load we want within there. And then one of the other things that we can do is have parameters. Now, these could actually be environment variables or they could be secrets. And I'll show you how to use both environment variables and secrets as we go through. And you might want to do that because in your JMeter script, you probably don't want to hard code things like the endpoint, for example. So if you want to do load testing against a certain endpoint, you don't necessarily want to hard code that inside of JMeter, so we can make that a variable inside the JMeter script, and then we can pass that through from our test that we create inside of the Azure Load Test service. The other thing that we've got here is a set of criteria. So we might say in our test, hey, we want to know if the error rate gets up above 10%, or maybe if the response time from the client side of you is more than 2000 milliseconds, then that is a criteria where we want that test to go and fail. Now, what happens from there is that if you go and spin up a test inside of Azure Load Test and you actually run it, what happens is that on your behalf, and this is where the kind of software as a service aspect of Azure Load Test comes in, there are these things called test engines. Test engines, excuse my handwriting there. And what happens is, let's say on the load here, we just said we want one test engine. Well, when you go and run this test, what actually happens is it submits that to a test engine, which is something that Microsoft hosts for you. It's not like you've got to go and spin up virtual machines or containers where all of this load testing is happening from. This is fully managed and you don't actually get these surfaced to you in any way. And these test engines, what they do is over here, we've got some sort of endpoint, right? Endpoint. And this endpoint, by the way, this could be non-Azure. So it could be something hosted off in another cloud or on premises or wherever you like. It doesn't have to be hosted in Azure. Or of course, it could be hosted inside of Azure itself. Now, there are some benefits if it's hosted inside of Azure, which I'll get to in a moment. Now, what happens here, let's say you're a user here on the left-hand side, and you go and manually go and kick off a test inside of the Azure Load Test service. That test will then spin up on a certain test engine, one by default, and that test engine will then start load testing this endpoint, whatever it might be. It needs to be publicly accessible because these test engines, they are hosted by Microsoft. So if your endpoint was behind some private networking, that's not going to work right now. It does need to be publicly exposed. But these test engines will sit here and let's say you said you wanted to simulate 1,000 users for 5 minutes. It'll sit there for 5 minutes. It'll be doing whatever tests that you've said against that endpoint. And what these test engines actually do, as well as testing against that endpoint, they actually kind of report back here. Let's go and pick a different color. We'll grab purple. And these report back into this Azure Load Test service with things that are known as client metrics. So these client metrics here are things like the response time from the test engine testing the endpoint. Are there any errors coming back? You know, those things that you're simulating here being a client just hitting an endpoint. You're not getting anything that's server related yet. We'll get to that in a moment. So these client metrics are here coming in from this test engine. And what happens from there is that inside of Azure Load Test, across here, let's go and grab a different color for this one. We'll go with red again. We have got a dashboard. And this dashboard is where all of this data from the client metrics is coming in real time. So you can see this when you actually run the test, and you can come back to this afterwards to see all of this information as well. So the test engine's there hitting the endpoint, client metrics are coming back into the dashboard, and you can see what the client perspective is of testing your application based on all of those parameters that you put in, like the load and the criteria and how many users you want to simulate and what endpoint they're actually hitting of your application. Now, just over here on the left-hand side, I said here, if you're a user, you can go and run a test, which you absolutely can. But some of the other interesting things is we can have things like Azure DevOps, or something that I'll show you today is GitHub Actions. And inside of those pipelines, those CI/CD tools, we can actually integrate it to go and run these tests here inside of our Azure Load Test service. And then based on different criteria that we set, remember we've got criteria across here in the test, based on that different criteria, we could have that pipeline either succeed or fail. So why might that be beneficial? Well, if you're deploying your applications using CI/CD, you go through the build process, you go through testing processes, and then you deploy it out to your endpoint. But wouldn't it be great to have a step in there to make sure that whatever changes you've made to your application are going to support the load that you anticipate being on the system? And then if you've introduced something that means that it can't scale to the load that you thought it was going to, then you can fail the pipeline and stop that deployment. So we will have a look at GitHub Actions as a demo in a short period of time. But what I want to do is finish off here in the overview, because over here on the right-hand side, let's say this endpoint over here actually was Azure. Your resources and your application are hosted in Microsoft Azure. So that could be something like, let's say, an app service. It could be sitting on maybe a virtual machine. You could have some storage related in there, maybe a database, maybe a storage account, something like that. You could have a container-based solution, maybe something like Kubernetes or Azure Container Instances. It doesn't really matter at this point in time. The main point is that all of these resources here are hosted across in Azure. Now, one of the benefits here of the Azure Load Test service is it is, of course, Azure. And these resources over here, these have all got metrics which are reporting back into Azure Monitor. And from a load test perspective, what we call these is server-based metrics. So up here in the middle of the load test service, we had the client metrics. So that's simulating a client perspective. What am I seeing in terms of response time and error rate when I go and reach out and use this endpoint? But down the bottom here, we can also start collecting these server metrics as well. So how was my web app actually performing when it was under load? What was happening to my storage account? Was there any latency in my application? And this is all coming back into Azure Monitor. And then this can hook back up into here, into this dashboard inside of the Azure Load Test service. And when you do this, you start to get this holistic view. So if those client metrics were starting to fail, then you can start to correlate that with your resources that are actually hosting the application and start to see what the bottlenecks are. And Microsoft have got a really good demo of this actually, and I'll show that to you in one of the demos coming up. Now, the last thing to finish off here is just back on these test engines. So before I said the recommendation from Microsoft over here in the JMeter script is to have 250 threads or virtual users. So that is simulating 250 users using your endpoint at the same time. That's kind of the maximum that they suggest on a single test engine. Now, the thing that you can do here is in your test, we said before that the load here might be 1, but let's say we could set the load here to 10. What happens there is Microsoft will simultaneously spin up more of these test engines inside of the load testing service. And I think at the moment, we'll have a look at this when we get into the portal, because it shows us in there. I think you can have 40 or maybe 50 of those test engines inside of there. And what they are doing is each one of those are at the same time going and hitting your endpoint, and they're also reporting back these client metrics into the Azure Load Test service. It's going and hitting the endpoint and reporting these back into the client metrics. So if you wanted to scale up, let's say, to 1,000 users, you might configure your JMeter script over here to have 250 threads or virtual users in it, and then you might set your load in your test here down to 4, and that will spin up 4 of these test engines here, which will effectively simulate 1,000 users hitting your endpoint. So at a high level, I'm looking at that. That does look a bit messy there. Hopefully you were able to follow along, and that is Azure Load Test at a high level at the overview of what it's doing. And I think a lot of this will make sense as we start to go through some of these demos. Now, just before we get into the demos, I do want to go and have a look at the pricing of this as well, because if you are going to follow along, there is a pricing implication. So let's check out the pricing, and then I'll show you what we'll do in the demos, and then we'll kick straight into the demos. So I'm just here at the Azure Load Testing pricing page on azure.microsoft.com, and I'll have a link to all of these down below in the description, and I'll have all the chapters here as well, by the way. I forgot to mention that in the introduction, but if you want to skip around, I'll do the chapters there as best I can for you. Now, the thing to note here to start with is that at the moment, this is indeed in preview. So this is Azure Load Testing preview pricing. So do make sure when you're going to use this service, if you're going to test it out, or if you're actually going to use it in production when it gets out of preview, make sure to come and check this out again, because things could have changed since then. But if I scroll down, we'll get down to the pricing table here. Now, this is in US dollars, so you can see here, but effectively there's 2 things to be aware of. And the first one is that there is the load test resource itself. So when we spin up Azure Load Test as a resource, which I'll do in this demo, by default, that will incur a $10 per month cost. Now, that cost includes 50 virtual user hours per month inside of that $10. So do be aware, if you go and do this, at a minimum, you will be paying $10 for the service. So I want to make that super clear because there is a cost involved. Now, the other thing here is that there is a virtual user hour additional usage. So if you use between 0 and 9,950 hours, that will cost you 15 cents per additional hour there. And if you go over that, then it is here at a discounted rate for each additional hour. So the way in which that is calculated, if I scroll down a little bit here, there is some FAQs and it says, what is a virtual user hour? So this is the number of virtual users simulated multiplied by the duration of the simulation in minutes divided by 60 minutes per hour. And Microsoft count the number of active virtual users every 10 seconds, and you are charged for the equivalent number of fractional virtual user hours that you use. So down here is a great example. If you simulate 1,000 virtual users for 30 minutes, you'll be charged for 500 virtual user hours. And I've found that this can ramp up pretty quickly as well. So do keep an eye on this and do be aware of how the pricing model is over here. When it comes to the demos, I've got a few things here that I want to show you. So I just want to talk through the agenda so you know what you'll get if you keep on watching. So first of all, we're going to just use the portal to go and provision an Azure Load Test resource. So we'll spin it up inside the portal. I'll show you some of the things as we're setting it up. And then we'll go and use we'll set up a test that will use a JMeter script, just a very basic one that's just doing a GET request. And I'll run that against my own site, which is a blog, mattalford.com. From there, we will use an argument or environment variable. So first of all, in that first test in the JMeter script, I will hardcode mattalford.com as the endpoint, and then we'll modify that to use an environment variable so that instead of hardcoding it into the JMeter script, we can pass that through at runtime when we run the test. From there, we'll look at integrating the Azure Load Test service with Azure Key Vault to use a secret. So I've got a demo simulated here where I've got an Azure function which requires a function key for it to be triggered successfully. And if you don't have that key, then you get a 401 unauthorized. So I've got that key saved in a Key Vault secret, and I'll show you how to integrate the Azure Load Test service with Azure Key Vault using a managed identity, and then go and pull through that secret value from the Key Vault and pass it through to a JMeter script. From there, Microsoft have got an application that has a bottleneck kind of built into it. So this is an application that has an app front end a web app front end and a Cosmos DB backend. I can't remember if there's anything else in there off the top of my head, but those are the two main components. And we'll spin that up manually using a PowerShell script to start with, and then run a test against it to see the bottleneck, and we'll identify where the issue sits. And then from there, we'll go and use that same application in a GitHub action workflow, and we'll see how it integrates with a pipeline tool. Now, it's pretty much the same in Azure DevOps as well. I'll show you GitHub Actions here today, but there are some demo scripts in that repository that we'll get to that have it set up for Azure DevOps as well. So whichever tool you want to use, you can obviously go and use that one. The prerequisites here, if you do want to follow along, first off, you'll need an Azure account because we're going to be spinning up plenty of stuff inside of Azure. And then you'll need an endpoint to run the load test against. So don't just go and run this against anything. You really should own the service that you're going to run this against. So in my case, that is going to be mattalford.com, which is my own blog. And then I'm going to spin up some resources from that Microsoft application, and I'm going to do my load testing against that. So please make sure you've got your own endpoint to run some tests against if that's something that you choose to do. Now, some of the optional stuff here, it depends what you want to follow along with, but if you want to go kind of from end to end, then you might need an endpoint that requires some sort of authorization or authentication. Like I said, my example here is going to be an Azure Function app just using a default container image I think I set it up with, and we need to pass through a function key to be able to trigger that. This one's definitely optional, but I will show you that there is a user interface for JMeter. So to start with, we'll just use some scripts which are just text files for JMeter itself. But there is a Java application that you can download, which might make it a bit easier to go through and build out these tests from a user interface perspective, rather than trying to read through the raw script files themselves. I'll be using Git to pull down the Git repository that Microsoft have got hosted for that test application. And then, of course, because I'll be doing my demo in GitHub Actions, I will need a GitHub account. And if you want to follow along, you'll need a GitHub account yourself. Hopefully, if you're watching, you've already got one set up. The last thing that you might need is Azure PowerShell and or the Azure CLI. So when we go through the GitHub configuration, I'll be using Azure CLI to set up a few things and Azure PowerShell to do a couple of the deployments manually of that application that Microsoft provide us as well. But like I said, all optional. It depends on what you want to follow along with, if anything. But I do suggest that you get hands-on. Now, if you do, like I said, there is a warning here. This is going to cost some dollars, not only for the Azure Load Test service itself, which will be a minimum of $10 US for the month. So make sure that you delete this after you're done as well, because if the month ticks over, then you'll be charged another $10. But if you spin up any of the other resources, such as a Key Vault or a function app, or that test application that Microsoft give us, then that is going to incur a cost as well. So please just do be aware of that. And with that, let's jump into the portal. We'll spin up a load test resource and we'll go through the process of doing a brief load test on my blog, which is mattorford.com. Okay, so here in the Azure portal, what I want to do at the top is just search up here for load test, and we want to go into Azure Load Testing. And then we simply want to spin up a new load testing resource here. So I'll click on the create button there, and that will launch the normal wizard for going and creating a resource here in Azure. So I need to switch that subscription across, and I'll put this in a new resource group. I'll just call it MA Load Test East US-RG. Now, I am being a little bit specific about the name of that resource group because a little later on in the demo, when we get to the GitHub actions and the script to automatically spin up those applications or those resources that Microsoft give us, they've got some things kind of hard-coded into their script about what the resource group will be named and what the load test resource will be named. So I want to use the same names here because I don't want to get to there and spin up a second load testing resource, which will cost me another $10 on top of this one here. So I am being a bit specific. Just watch out for that if you do go through this, and make sure that you're aware of what those resources will be called if you go and use the scripts to spin them up. So we'll go MA Load Test East US there. And for the name of the load testing resource itself, I want MA Load Testing 01. And we will host that across in East US. I don't need any tags, and that is actually all there is to creating the load test resource. Now, there is one important thing here about the location. You'll notice at the moment in preview, there are only a select number of locations here. I think we've got 5 there at the moment. And this is somewhat important because remember those test engines that we spoke about in the overview where your load test will actually get ran from? Well, this is the region here, or the location, where Microsoft will run those instances that are going to go and test your endpoint. So if you want to simulate your users, for example, maybe being across in Australia East, then you'll need to pick Australia East for the load testing resource location here to control where those test engines get provisioned. I'm not sure if that's something that they'll allow you to change in the future. Maybe down the track you can create a load testing resource, which is that overall holistic container of information, and then you can potentially be specific about where your test instances will be located. But at the moment, that's how it is, so just do be aware of that as well. So let's go review and create there, and then that'll go through the standard validation of Azure Resource Manager. And what did I miss? How could I have missed something there? Oh, look at that. The name MA Load Testing 01 is already taken. I think I know where that is. I'm going to pause this video, go and delete that, and I'll come back to here. And there we go. That's what I get for demoing this and then not cleaning up after myself. So we've got the tick there. Let's go ahead and review and create again. And hopefully this time it passes the validation. And I guess that is one other thing. There we go, validation pass. So I'll hit create there. And that is one other thing to be aware of, I guess, is that every Azure load testing resource that you spins up needs to have that globally unique name, which is pretty common across some Azure services, not all of them, but obviously we need that with Azure load testing here as well. So let's go ahead and we'll wait for that to spin up. Actually, while that spins up there is something here that I wanted to show you, and that is the different roles with role-based access control in Azure that have been created for Azure load testing. And I've bookmarked a page here under the documentation, which is for managing users and roles. And we can see here that Azure load testing resources have 3 built-in roles that are available by default. So we start with the load test reader. So users with this level of access has read-only access to the load testing resource. So they can list and view tests and test runs in the resource, but they can't create, update, or run any tests. And then we have load test contributor here. So these people can view, create, edit, or delete tests and run tests in a load testing resource. And then finally down the bottom here, there is load test owner, and they can basically do anything inside of a load testing resource. Now, something else to be aware of down here is if you have the owner, contributor, or the load test owner role at the subscription level, you automatically have the same permissions as the load test owner. So if someone is an owner or a contributor on your Azure subscription, they will also automatically be a load test owner here. So just something to be aware of. Let's go and see how that deployment is going, and that is complete. That looks good. So let's go across to that resource group, and inside of here, we should just have one resource at the moment, which will be the Azure Load Testing service. There it is, MA Load Testing 01. And as I open that up here, we just get an overview of the service. So there's not a whole lot to it, to be honest. On the left-hand side here, let's have a look at a few of these things. So we've got overview, which is where we are at the moment. That's pretty standard, as is the activity log for seeing who's done what to this particular resource. We've got IAM, which is the access control there. So like we just spoke about with the roles, if you wanted to give someone reader access just to this load testing service so they could come in and view the results of a load test maybe, then you can go into the access control there specifically on this load test resource and maybe give them that Azure Load Test reader role on there. We've got tags, which are pretty common across all of the Azure services. Down here is where we actually go to create a new test or run some tests, and that's where we'll spend most of our time throughout this demo here. Down under here, under settings, we've got identity. So that's where we can set up a managed identity or a user assigned identity. And at the moment for Azure Load Testing, that is mostly so that it can get access to Azure Key Vault. Again, that is something that I'll show you as we work our way through here. So let's start off by going into tests here, and we'll create a stock standard test. So we'll go to create test up the top there. So in here, we've got a bunch of tabs at the top that we need to work through. But first of all, let's give this test a name, and I'll just say it's for mattorford.com. And a test description is optional. Let's just say it's a GET request against mattorford.com, and we will run the test after creation here. So let's move our way along to the test plan. And what it's asking here is to upload one JMeter script. And the JMeter script is where it's going to have all of the configuration of what those test engines actually need to do. What endpoint do they need to go and hit? What sort of requests are they doing? Are they doing GET requests against a certain URL? Are they doing POST requests? Do they need to send any headers with the request across? Do they need to do any authentication? All that sort of stuff is contained inside of that JMeter script. Now at the moment we don't have one, so we kind of need to pause here and go and create one. And there's another page here on the Microsoft Docs for creating and running a load test. And they have this here, which is a sample test.jmx. So JMX is the extension of a JMeter script. And they've got this sample here, which is actually going and doing exactly what I want. So I'm going to copy that, and then across in Visual Studio Code, I'm just going to launch a new file here and paste that information in there. And I'll walk through this kind of really briefly with you, but I also just want to save that. And just in here in this Azure Load Test folder is fine. And I'll just call this mattorford.jmx. And we want to set that just to all files there so we get the JMX extension. So I'm not going to walk through every single setting there is here with you. You can obviously go and do this yourself and have a look through the documentation. But there's a few key things that I do want to point out. And for example, down here, we've got the number of threads. So that is effectively how many virtual users we want in this test. And at the moment, that's set to 5. I'm going to change that in a moment. And then we've got this here, which is the ramp time. So that is the time in seconds, I believe, on how long those 5 users, in this case, will take to ramp up. So if we're running our test, which we are down the bottom here under duration for 120 seconds, then those 5 users that we've got at the top here, they are going to take 10 seconds to ramp up. So probably about every 2 seconds when you start the test, another user will get added on. And when we're 10 seconds into the test, we'll have our 5 users, and then that will just sustain for the rest of the test. So all of these configurations here are around how fast you want to ramp up your users and how many users overall you want. Now I'm going to change a couple of these configurations. We're going to say we want 10 threads here, and I want them to ramp up over the course of 20 seconds. And I just want the test here to run for 60 seconds. That is absolutely fine. Now, as we scroll down a little further, this here is the sampler proxy, and this is the endpoint and a lot of the information about the endpoint that we want to hit. So we can see here that there is a HTTP sampler domain, which it just says at the moment in this example is your endpoint URL. And then there's things in here, and we'll get into a different couple of configs as we move along. But for example, we've got a path. So the endpoint URL is kind of the base domain. So mine is going to be mattorford.com. But if I wanted to start testing, /API/version1/whatever, then I'd put that in here as the path. And then we've got the actual method that we want to do. So at the moment that is set to a get, but we could do post requests, we could do deletes, anything in that REST API spec we can do in there. So for now, let me change this and we'll go mattalford.com. And we don't need any path. We'll just go to the root of my blog and we'll do get requests against it. That is absolutely fine. And that is all that I wanted to change there. So I'm just going to save that JMX and we'll jump back over to the portal. And now I can select that as my JMeter script to upload into this specific test. So I had that sitting here in a folder called Azure Load Test and we'll upload that there. When it uploads this, you can see there it's done a validation up the top right as well, and we've got a green tick down here. So that is all looking good. So let's go next to parameters. Now I don't need any of these at the moment, but there's kind of two different parameter types that you can set in here. The first one are environment variables. So these are non-sensitive parameters that are exposed as environment variables for access by the test engine when it gets ran. And then down here, we've got secrets down here. So these are sensitive parameters. So I'll show you an example of both of these as we move forward, but a secret needs to be pulled at this point in time from Azure Key Vault because you don't want this to be exposed anywhere in plain text because you're probably passing something like an API key or a password or something like that through to the test engine that it needs to run against your endpoint. So for now, I don't need anything in there, but we'll come back and revisit that as we go. The load here is what I mentioned in the overview. And you can actually see at the top here that you should set the number of threads in the JMX script to a max of 250. So this represents the number of threads executed by a single test instance. And you can see down here, we've got this slider where we can go from 1 and was I right? 45, there we go. So this number is probably prone to change over time. But let's say we had 250 users in our JMeter file. We could set this to 4 to get a simulation of 1,000 users for the overall test. But for now, I just need that set to 1 because I'm only just doing a basic test here of 20 users. But that is how you can change the load that you want against your endpoint. On the next page, we've got some test criteria. And these are some criteria that we can put in here. And based on this criteria, these are kind of failure criteria. So for example, in the metric here, if I say the response time is an average, which is greater than, let's say we'll go for now 2000 milliseconds. So during my test, if the response time from the client perspective, so this is those test engines that are hitting my endpoint, if the response time on average is greater than 2000 milliseconds, then the test is going to fail. It won't pass. The other one we can do at the moment here is an error rate. So if the percentage of errors is greater than, let's say 5%. So of all of my requests, if more than 5 of them return some sort of error, then I want the test to fail as well. And these become pretty important when we get down to the pipelines as well, because we build in these test criteria, and that determines if the task in the pipeline actually succeeds or fails, which then impacts what you should do after that. So just keep that in the back of your mind for when we get to the pipeline stuff a bit later on. Monitoring, I'm going to come back to in a demo coming up. This is where we can add back-end resources from Azure to get those server-side metrics into the dashboard. But for now, we'll just leave that empty. We won't add any resources in there. So we'll skip here to review and create. The validation has passed there. That all looks good. So let's go ahead and create this test. And remember, right at the start of that, I had the box ticked to start a test automatically when we create this test. So we can see at the top right there that the test has started. We can see here the test has run shortly. And over here on the right-hand side, the status is currently provisioning. I think in a moment that will go from provisioning to executing, and then we'll start getting some data in here. So let me just speed that up to when we've got some results in here. We can see the status there has changed to executing, and actually up the top right there, you'll see that auto refresh is set to, auto refresh was set to be on every 5 seconds. You can turn that auto refresh off if you want, but I like it being on for the 5 seconds because as the test starts to ramp up, we can start seeing the data here in real time. So let's let this start up and start testing my endpoint, which is mattalford.com. Okay, it looks like we've got some information in here. So as I scroll down, we've got some test criteria here. So we can see that response time of 2000 milliseconds there and the error percentage being greater than 5 for the criteria of when it should fail. And as I scroll further down, These are those client-side metrics that we spoke about in the overview. So this is what the test engine is seeing when it's testing my endpoint of mattorford.com. We can see here we've got a bunch of virtual users and they ramped up over the course of a few seconds here. And over here on the right-hand side, we've got a chart for the response time. So we can see it did take initially 1.5 seconds, but it's bounced right down probably as it loaded that for the first time. My blog probably hasn't been hit in a little while. We can see the response time has dropped right down. And as I close that, we can see this is updating in real time as well. As I scroll down a little bit more, look at that. We did actually get a couple of errors there. There were some errors. We got a 409 at some point there during the test. And we can see the requests over here on the left-hand side as to how many requests are being sent on average to that service. And I think those are all of the client-side metrics. We've got some more server-side metrics down the bottom here, which we will explore in a later demo. So let's go ahead and we'll let that test. Oh, it's actually finished already. There we go. So at the top here, we can see some test run details. So we've got the start time, we've got the end time, the number of instances that were spun up to run the test, and we can see we've got a test result here, which was passed. So we did get some errors, but as we can see down here, the error percentage was only 0.04%. So it was nowhere near that 5% threshold that I set. And the response time there looks great as well. That was 305 milliseconds. And we had a success criteria, or a failure criteria rather, of 2000 milliseconds. So that all looks pretty good. What I'm going to do from here, actually before I do, there are a few things that I want to show at the top here. So if we wanted to, we could delete this test, we could share it, we could download it. So we can actually download the logs, or we could download the results as well. So if you wanted to take the results from this test and load them into some sort of other application or do something else with that data, you can download them, which comes down as a zip there. But if we actually open that up, it is just a CSV file, which has got all of the data from that test and that specific run that we just did. So you can go and download it. We can do a compare, which is what I'm going to show you in just a moment here. We could refresh here. If we didn't have that auto refresh on, you could manually go and refresh the page, or we could do a rerun of that specific test that we've set up here. So if we go to view all test runs, this kind of takes us back a level, I guess you could say. So we set up a test for mattorford.com, and we've only ran one test against it here. And it kind of gives a quick overview in here. You know, what was the duration? How many users did we have? What was the result? And what is the status? So as I go and run more tests, and I'm going to run another one here in a minute, we'll kind of see the history of all of the tests bank up inside of this single test that we've created inside of the Azure Load Test service. So what I'm going to do is I'm going to go and run this again. And when I run it now, I don't have to go through all of that configuration again because we set that up for the individual test. And it says here that the test will run using the following settings. It's going to use the JMX file from mattorford.com. It will use the latest configuration and the latest app components. Now, just let me cancel that. If I did want to change the configuration between runs, I can use this configure button here to go and do that. So I could say, hey, I actually want to configure the test and I want to make a few changes. And that'll take us back into that same page before. So if you've gone and updated your JMeter script and you've got a change that you want to upload, or maybe you want to change the load here from 1 to 5 or modify the criteria, you could go and do that and then rerun the test. But I don't want to change any of those, so I'll come back to here. I'll click on run and just let me run another one of these tests and then I'll show you a comparison. So there we go. You can see I've now got two tests. Using this test, I've ran that test twice. So I've got two sets of results here. We've got the run that I just did now at 4:23 and the one that I did with you, which was at 4:18. So what we could do is we could select both of these tests here, and then up the top here, there's this compare button. And this allows us to compare a maximum of 5 tests, and they have to be in a done, stopped, or failed state to be able to compare them. So maybe you've gone and ran a test and you noticed an obscure set of results, or you've noticed a bottleneck in your application and you've gone and made a change. You can come back and run another test, and then you can do a comparison here. And it kind of shows you here in line as I scroll down. You can see one of these results has got a dotted line as it ramps up, and another one has got a solid line. Those are the two different tests that we've done, and this is comparing them from the client metrics at the same time. So as I scroll down, we can see that the second time we had no errors at all. It was only in that first run that we got a set of errors. And we can see that, you know, the virtual users ramped up pretty much at the same time. the response time was pretty much the same there going along, and the requests per second on average, again, was pretty much the same. So not a huge difference there, apart from the errors. That is something. The first time that we ran it, we did get an error come through, but the second time, no error at all. So that is how you can do a comparison of the tests. Now, let me go back here, and what I want to do is I'm going to go all the way back actually to the load test service, just into the tests here, and do a refresh. So we've got the test there for mattorford.com, which we've now ran twice. But what I want to do is use a parameter, which is an environment variable, to pass through the URL that we're going to test against. So down here in Visual Studio Code, I've got another JMX file that I did pre-prepare, and it is exactly the same as the one that we just used. So there isn't much to show, apart from, as I scroll down, we do have this section here, which is different, which is an argument in JMeter. And there's a few interesting things here. So firstly, I'm just going to scroll across a little bit because my text at the moment there is pretty big. And what I want to show is a couple of things. First of all, this argument here, it has a name of UDV_endpoint. Now, you can call it whatever you want. I just noticed when I was going through this myself that there seems to be a little bit of a pattern for putting it as UDV_, and that stands for user-defined variable. You can call it whatever you want though. It doesn't have to be that. So, down here is actually the argument name, which is UDV_endpoint. This is just an actual name of the element up here. So this is the actual value down here as to what it's called. And then down here is the interesting part, which is the argument value. And we can see it's got this _ beanshell system.getEnv and then endpoint in parentheses. Now, this here is just the syntax that's used in JMeter to load in an environment variable. The important part here, at least in my opinion, is here, which is the name of the variable to go and get, which is endpoint. So what that says to us is when we run this load test in Azure Load Test Service, we need to provide an environment variable, which has a name endpoint, and it needs to have a value. And how that actually gets used in this JMeter file, if I scroll up a little bit, is up here. You can see this syntax, which is for $ and then an opening and closing curly bracket, and then the name of the argument in this JMeter script. So remember the name of it down the very bottom here was UDV_endpoint. So up here we've got $, opening curly bracket, and then the name, which is UDV_web endpoint. So instead of hard coding in mattorford.com like we had in the last one, we've now got an argument, and we're going to pass that in using an environment variable in the Azure Load Test. So let me go back across here to the Azure portal. We'll go back into that same test. I could go and create another test here. Remember, you can create as many tests as you want. You don't get charged based on the tests themselves. You get charged by Microsoft or by Azure based on the virtual users that you use. So that runtime that you run these tests for. But I'm just going to go back into this test that we already created, and I'm going to edit this one rather than creating a new one. Much of a muchness really though. So up here I'll go to configure, and I want to configure the test. And then over here on the test plan, I need to upload that new JMeter script where we've got the one that's got the argument in it. So I've called that mattorford parameter test. So I'll open that, and a JMX has already been uploaded. So because I'm editing in one here, I need to remove that existing JMX, and now it will allow me to upload that new one with the parameter. That is validated okay. Now, if I went and ran this right now without putting that environment variable in, it'd run, but it wouldn't run against anything because I haven't told it what endpoint to go and do the testing against. So across here under the parameters tab, this is where we need to specify an environment variable. And if you remember, the name of it was simply endpoint, and then we need to pass in a value. So this can be whatever the endpoint is that will end up being the host name in the JMeter script. So for me, that was mattorford.com. So the power here, as you can see, is that I can start to build out a library of JMeter scripts that can test different endpoints without having them hard-coded in. So I might have 3 or 4 different applications that I want to run the same load test against, but I don't want to hard-code the app. So I could have one JMeter script and then just use environment variables in different tests in the Azure Load Test service to go and test those different endpoints. That is all we need there, so I'll apply that. And to be honest, there's not going to be much of interest here because it should work just exactly the same as our last test did, because it'll go and test mattorford.com using those same values that we had in the JMeter script. So if I go here into the test, mattorford.com, and just to make sure it worked, I will kick off a run here. Now, this is interesting. and something I should have pointed out. Now that we've got an argument in the JMeter script, when I click on run this time, it's asking me, do I want to override any of the values here? So we can see down here, if I scroll down, we've got environment variables, and we configured this in the test, right? So we configured an endpoint to be mattorford.com. But if I wanted to run this test ad hoc in the portal, I can actually come in here and override this in real time if I wanted to. So this is a run preview, and it's saying that the test here will run using the JMX file from mattorford.com, the latest configuration, and the latest app components. But if I did want to override it here, I could do that before I click on the run button. So that was slightly different to what we saw before when it was all hard-coded. But that's okay for now. I'll just click on run there. I'll come back in a moment or two and we'll see if that ran successfully. Now that test has finished there. We can see that at the top we've got the test run. Now we've got a test result here of failed, and I thought I'd leave this in because I've made an error and I wanted to show this to you, and then I'll go and fix it up. I know what I've done here. So if I go into this test run, we'll see here that the result was failed, and the error percentage, have a look at this. It was 100% failure. So something has clearly gone wrong. As I scroll down, we can see here that the errors are way up there, and we've got a homepage error. So non-HTTP response code. So something was definitely wrong. Now, what I did was, this is my own fault. Back in here in the JMX file, I actually had a typo, and you might have already noticed this as I went through, and I should have picked up on this. But what you can see here is down here for the argument name, I had UDV underscore endpoint, and I was pulling in an environment variable of endpoint. That's all fine. But up here at the top, where I actually had the domain, I'd played around with these files a few times, and at some point I was actually calling the argument UDV underscore web endpoint rather than just UDV underscore endpoint. So all I need to do here is take web out, and now this actually matches up. So I will save that JMX file. Let me go back into the test. I'm going to edit it here again, upload the JMX again, rerun it, and we'll see what happens. I'll be back in a moment. And there we go. That all looks a little bit better now. So we can see that last run there has worked okay. We have now got the pass result under test, and it is all good. So that is a good example to make sure that all of your configurations there for the name of the argument and where you're using it somewhere else in the JMeter script, that they all match up. Kind of glad I made a mistake to show you that it's not all unicorns and rainbows as you go through making these demos, right? So what I want to move on to next is doing a load test against an endpoint that might need some sort of authentication or authorization to be able to run it against. So you're not always going to have just an open endpoint that you can go and do this against. Do GET requests or POST requests. Your application, it's probably going to have some sort of login process. And then when you're logged into it, you might need to do a certain number of actions within it to actually test the viability of the service and the load and everything like that. So let's go and do that. Now, what I've got here, let's jump across to the function app. So I'll just show you what I've got at a really high level. It is nothing too fancy. You can go ahead and recreate this yourself as well. So I've got a function app running here. I've just called it Azure Load Test FCN because I'm a super creative person. And when this loads up here, we'll see that under functions, that I've got a single HTTP trigger function there, just called HTTP trigger 1. It is just kind of the default. It is absolutely nothing fancy. And in here, if I go and do a get function URL, we can see that it's got the name of the function app here, which is Azure Load Test FCN.azurewebsites.net/API/HTTP trigger 1. And then it's got a code at the end, starting with AZ and then this long code here. Now that code is a function key that we need to send through to this function app for it to actually trigger. So if I copy that to the clipboard and just go to a new browser tab here and paste that in, then that'll go and hit that function, the HTTP trigger 1, and there we go, we get a response back. So it says this HTTP triggered function executed successfully, pass a name in the query string or in the request body for a personalized response. So this function is one of the default ones that Microsoft provide, and the idea is that you pass a key value pair with name and a value, maybe your own name, and pass it through, and it will do something different and send you back a different response. But what this means here is that it worked because we passed through that function key. Now, if I modify this URL here and I take all of that out, so we're just trying to hit HTTP trigger 1, the function itself, what I will get back here is a HTTP error 401. This page isn't working right now. And that is an unauthorized because I'm trying to trigger that function using HTTP, but I'm not passing through the function key, which is required. So if I wanted to do some Azure load testing against this service, I can't just send in this host name here with this path at the end of /API/HTTP trigger1. I also need to send in the function key for it to work properly. Now, the function key is something pretty secretive, and it's not something that we just want to paste into our JMX file as a URL. We want to pass that through using a secret. And the way we do that with Azure Load Testing is by leveraging Azure Key Vault. So let me go back to the portal here. And like they say, here's one I prepared earlier. So if we go and have a look at the key vaults, I have a key vault here just called load test-kv-01. And at the moment, just under access policies, we will come back to this in a moment, but we can see the only access policy here is for myself to get access into the key vault. And if we go into secrets, I have created a secret here called function key. And if we have a look at the only version that I've got of that and scroll down a little bit, if I show the secret value there, down here you can see that secret value, and it is just that string of the function key. It's not the full URL or anything like that. It is just the function key that we need to pass in as a header or at the end of a string as a parameter when we try and execute that function. So I've got the key vault set up already. I've got the secret there set up with my secret value. That is all good to go. So how does this actually work? Well, let's go back to VS Code. And again, I've got a file here called function-secret-test. And there's probably a few things to have a look at inside of this one. As I scroll down here, I do have the same number of threads. I've got the same ramp time and I've got the same duration. So nothing too different there. Down here for the HTTP sampler domain, we've got Azure Load Test fcn.azurewebsites.net. So I am hard coding that into this JMeter script here. I'm not passing it in as an environment variable. That's fine. You've just seen how to do that if you did want to do that. But that is the URL to my Azure function that I'm hosting there inside of Microsoft Azure. Now down here, under the sampler path, you can see I'm doing a /API/HTTP trigger1. So we've got the domain, which is the top level domain, Azure Load Test fcn.azurewebsites.net. But then the path that I want to hit is /API/HTTP trigger1. And then I'm just doing a get request here. Nothing too fancy. I just want to get the information. But the thing of interest as I keep scrolling down is here. And here is the header manager within JMeter. And this is where I want to send in some headers with that API request, or with that GET request rather. And we can see that I've got a header name, which in this case is x-functions-key. So that is the name of the header that I want to send in to my function when I execute it. And the value that I want to give it is down here. So this is the header value, which again is using this syntax of $ and then a curly bracket and then the name of an argument. So the argument in this case is UDV_function key. So hopefully that makes sense there. I'm sending in a header and a value. Sorry, I'm sending in a header name and a value there. And the header name is x functions key, and the value is an argument in JMeter. So as we keep scrolling down here, we've got some arguments. So this is pretty much the same as before when we just showed you the hostname one, but now I've got one that is called UDV_function key. And what it's doing this time is something slightly different. Instead of doing a get env like it was before, this one here in the value you can see is doing a get secret, and it is getting the secret named function key. So all in all, when we load this JMX file into the Azure Load Test service, it is expecting us to provide a secret called function key. And let's go and do that now. I'll make sure that that is saved there and jump back into the portal. Now there is something that we need to do in our load test service to go and enable us to get that secret from Key Vault. And what we need to do is enable an identity, which is done down here under settings. Now there's two choices here. There's a system assigned identity or a user assigned identity. System assigned basically means that it is tied to this service and you can only have one of those, and it creates an Azure Active Directory identity that we can then go and use to give it access to other resources within Azure. So that's what I'm going to do here. A user assigned one is a totally separate resource that you can create in Azure and then use. Different resources can use a single user assigned identity. You can have more than one of them to authenticate to different resources as well. But for now, I'm just going to keep it simple and we'll do a system assigned identity. So I'm just going to toggle this status here to on and go and save that, which will register it with Azure Active Directory, and it will create an identity for this Azure Load Testing service. And there we go. That has now gone and been enabled. And we can see that we've got here the object ID or the principal ID. And that is what we need to assign this load testing resource access elsewhere inside of Azure. So I'm going to copy that to the clipboard, and then we're going to jump back into the key vault here. And just using an access policy, with key vaults, you can use role-based access control, or you can use access policies. I'm not going to get into that right now. It's a bit out of scope for us here. But I'm going to add an access policy that is going to allow the load testing service access to go in and get that secret. So we'll add an access policy here. And all we want it to do is be able to get secrets from this key vault. It doesn't need to be able to do anything else. So we'll scope it there. And here under the principal, I've just clicked on none selected there, and it brings up this search box over here. So I'll paste in that object ID, which has got a name, which is the same as the Azure resource, which is MA Load Testing 01. So that is what we want. I'll select that and add that in. And with the access policies here, do be aware you need to save them at the top. And as I scroll down now, we can see here that I've got access into this key vault, and we've also got an application that's got access here, which is MA Load Testing 01. And that has got access under secrets to go and get the secrets from there. So that allows our load testing service access to this key vault. So the other thing I want to do while I'm here is back under secrets for function key. I need to get the URI of this function key because that's what we need to pass in as the value when we go and do our load test. So just here for the secret identifier, it has got a value here. And that is actually for this specific version. And that would be okay. I'll just copy that. You don't need to tie it to a specific version. If you didn't want to tie it to a specific version, you can just leave this bit off the end, which is this specific version of that secret. I'm just going to paste that in there in my notes. And what we'll do now is go back to the Azure Load Testing service, and we'll create a new load test for the function app. So back here under tests, I'm going to go and create a new test. And let's call this one here, we'll call it function app secret. We will run it after creation, that is fine. For the test plan in this one, I want to upload that different JMX, which is the function secret test, and I'll upload that here. It'll go and do the validation, and that looks good. So here under parameters, this is where we need to pass in a secret here. So remember, this is a sensitive parameter that's required for running the load test. So if I tried to run this load test now against my function app, it's just not going to work because it doesn't have that function key. So here under the name, I think we called it function key. And for the value, I think that's still on my clipboard, it is. So the value here is just the identifier of that secret inside of Key Vault. And like I said, you don't have to tie it to a specific version at the end there. You could leave that off and it will just automatically get the latest version of that specific secret. Now, down the bottom here, there is a Key Vault reference identity. And by default, it will use the system assigned identity there, which is good because that's what we've configured. But if you had gone and configured a user assigned identity instead of system assigned, you will then need to go and choose which user assigned identity you want to use in this test. So you might have a scenario where you've got a bunch of different key vaults and a bunch of different endpoints and a bunch of different tests. And you can create a user assigned identity that gives access just to specific key vaults and getting those secrets. And then in this test configuration, you could say, hey, I just want to use the third user assigned identity because that's the one that's got specific access into this specific key vault. So if you wanted to get very granular with configurations like that, you can absolutely do that. But for now, we are just going to use the system assigned identity. The load we're going to leave at one engine instance, that's fine. We won't do any test criteria here. We'll just go and let it do its thing. But what we will do is under monitoring, let's have a look at some of these server-side metrics. So what I can do here is click on add/modify. And this brings up by default all of the resources in my Azure subscription. And what I can do is I can select, hey, what are my backend resources that is hosting this application? And that is going to then go and correlate those server-side metrics with the client-side metrics as it goes and does this load test for me. So everything I've got, I'm just going to sort here by the resource group to make sure that I grab everything. which is stored here in this load test function app. So I don't really need the key vault, but hey, let's select it anyway. We've got a storage account there that the function uses, the app service plan, the function app, and application insights as well. So I'm going to select all of those different Azure resources and apply that and pull them into the monitoring component here. There we go. Everything's loaded in there. And from there, we'll just go on review and create. The validation has passed. So let me go and create this second test inside of the Azure Load Test service. This is going out against the function app that we created, or that I created rather, and it's going to be using that key vault secret with the value of the function key to pass through as a header in the JMeter configuration to actually go and trigger that function inside of the function app. So let's keep an eye on this here as it loads up. Okay, I can see some data coming in now. So we've got some client-side metrics here. Over here on the left-hand side, we've got these virtual users. So we can see that starting to ramp up there. The response time, that's actually looking good. We are getting a response time, which means that we're getting some successful responses, which is obviously a good sign. Requests per second looks good there. That's starting to ramp up. And there's no errors being reported yet. So that tells me from the client side that, hey, we are looking good. It is actually triggering the function and it's not getting the 401 unauthorized because we are sending through the secret value from Key Vault with our requests in the JMeter file using those headers. Now, the interesting part here, if I keep scrolling down, we didn't have this last time, but now we have got these server-side metrics here. And there's a bunch of these, whoops, a bit wonky there on that. I think you know what I meant, server-side metrics. There we go. Now, as I scroll down, we've got a bunch of different metrics coming in. So we can see here we've got a few from Key Vault. We're getting total service API hits, the availability, and the latency. As I keep scrolling down, we've got some storage account metrics here. We've got availability, used capacity. As I keep going down, we've got some app service, the CPU percentage and the memory percentage here, and then some metrics from the function app itself. So how many requests, what's the response time from that point of view, what's the server response time from App Insights, any failed requests that have come through App Insights, so on and so forth. So that is refreshing there. Let me go and do a manual refresh and we'll see there can be a little bit of a lag here as Azure Monitor kind of catches up. So I'm just doing a hard refresh there. We can see at the top that the test is actually finished. It ran for 1 minute. There were no errors at all. Response time was 254 milliseconds. That all looks pretty good from a client perspective. But let's just wait for, here we go. We've got some data here now. So we can see for the function app itself, this was the requests. So we basically had nothing at all. And then the requests here have ramped up to 2,000 requests. So we can see from the server side, from the function app, you know, the thing that's behind the scenes hosting this application, we did see that ramp up as the users in the load testing service ramped up. And we can see, as expected, the response time of the function app also went up as well as the load increased. If I scroll down a little bit here, we've got the server requests in App Insights that have ramped up, and we should see some increase. Yeah, we do. The CPU percentage, for example, on the app service plan, this was basically doing nothing down here, and then it went and ramped up to almost 60%. So we could start to now correlate, and we'll see this a bit better in the next demo where we go and use an application that actually has a bottleneck in it. But you could start to see, hey, here's what's happening from my client side. And now right from this same dashboard and this same set of data, I've now got insights into my backend as well. And you can correlate that. So before, when we went and did my blog and the test against that, if I was getting some errors there, I'd then have to go and dig off into my specific service, wherever that's hosted, and go and have a look and try and correlate the timestamps and see what's happening. But I really love this view here. I think there's a lot of power. If you're hosting your application inside of Azure, you can hook in these here and to your load test and actually see in real time what your backend is doing, as well as the front end from those client metrics as well. The other thing here just on these metrics is you can configure them as well. So when I selected those resources, there's a bunch of default metrics that someone at Microsoft have picked as being the best ones. But if we come up here to configure metrics, you can actually override some of those metrics that are there. So we can see that, for example, at the top here, we've got 3 different metrics for key vaults. We had the availability, the total service API hits, and the overall service API latency. And you can see the aggregation over here was average, and then count, and then average. But if that's not what you wanted to see from those resources, if you were maybe not interested in some of those, you will come and delete them here on the right-hand side. And let's say for the Microsoft websites, you wanted a different metric in here. You can come and add in something if you want, But let's say you wanted specifically to see, all HTTP server errors, not just specific ones. You could change that here to HTTP server errors, and instead of the total, maybe we just wanted to see the count. You can come in here and you can modify these metrics. So there's some good ones by default when you pick a resource, but you can absolutely come in here and override these metrics to be something that's more relevant to what you want to see when you're doing your own load tests. Now, do be aware, because we just did that load test then, it's not going to change what we were seeing in that test run. If I went and changed these metrics here, I'd need to come down and apply that, and then that would get applied to future runs. It doesn't get applied retrospectively to runs of a load test that I've already done. So just do be aware of that. I'd need to rerun that now to see those updates here. But that is everything kind of on the secret side of use. And that's what this demo was really around. It was showing you, hey, here's something that's behind some sort of authentication or authorization. In my case, it was just a simple function app, but you need to pass a secret through, a password or an API key or an authorization key, something like that. You can go and store that inside of Azure Key Vault, use a managed identity, a system assigned identity, or a user assigned identity to hook Azure Load Testing into the Key Vault and pull out that secret and pass it straight through to the JMeter script as an argument that then gets used somewhere else in the JMeter script, whether that's in the URL or maybe as a header like I did in that example there. So with that, there's one other thing here that I want to show before we move on to the next demo, and I thought this might be a good time to do it. But there is, I mentioned in the overview, there is a user interface to JMeter as well. So you might be looking at some of those JMeter scripts that I've shown you and thought, wow, that's a lot to try and wrap my head around. And it is. I'm pretty new to JMeter myself. But what I've got here, I think it's in my downloads folder. You can go and download a user interface for JMeter, and I'll have a link to this. There's a web page where you just go and download it. And for for Windows, it just extracts into a folder like this. So it is a Java application, so you need to have Java installed. But if I come into this bin directory here, and then there's a JMeter Windows batch file here, and if I just right click on that, and I'll run that as administrator. I don't know if that's actually required, but let's do that just in case it is. That'll run a batch file, which then goes and launches a JMeter user application. Now, the JMeter application here is not actually for doing any load testing. There's no engine here to run these tests from. It is just for creating tests and debugging tests and going and maybe modifying some of the information here. So for example, let me just go up to File and Open, and I'll open up one of those tests that we had. So I've got those back in this PC in my C drive. I've just got a directory here called Azure Load Test. Let's go and open up the function secret test one. So that comes and opens up this test here in the JMeter UI. So we can see some interesting things like the number of threads was 10. That's what I set it to in that JMX file. And the ramp up period in seconds was 20 seconds. And the duration that I wanted to run for was 60 seconds. Now, if I wanted to, I could modify this here as well. So if I thought, hey, I want to run my test now for 120 seconds, I could do that here. And then I could just go ahead and save my plan. And I could override the file or create a new one, and it will go and create a JMX file for me from all of the settings that are here in the user interface. So as we expand this out, we can see down here that inside of this test file, we had a HTTP request, and the name of that was just called function. Let me just move this down a little. There's nothing actually to see there, but we can start to see some more interesting things here. The server name or the IP address that we were hitting was Azure Load Test fcn.azurewebsites.net. The HTTP request, we were doing a GET request. The path was API HTTP trigger 1. So again, if you wanted to change any of these, if you wanted to start doing a post request instead, obviously those are pretty simple things to change inside of a JMX file, but you can use this here to come and add these specific configurations in and generate that JMX for you, rather than having to do it all by that text file. Now, as you get good with it and familiar with it, you'll probably know a lot better on how to do that. But again, down here under the HTTP headers, we've got a header here for the X functions key, and the value was an argument that's being passed through, which is over here under the user-defined variables. This time we had a user-defined variable, which was the function key, and the value was doing a get secret from when we did the Azure load test of something called function key. So that's where we're passing it in from. So down here, you could come down to the bottom and you could add in a new variable here if you wanted to. So, hey, I want to add, UDV underscore new variable. And so this user interface can be really handy to come in here and get a good graphical view of what you can do inside of the testing. There's a bunch of stuff. It's a really complex and really powerful test engine, which is why Microsoft have picked it for Azure Load Testing. But I thought I'd just point out that there is a user interface here for Apache JMeter. The version I'm running at the moment is 5.4.3, but I'll link out to that in the description below. And you might find that it's helpful as you go through creating your own test files and working with the Azure Load Testing service. So this next demo that I want to show you is using a application that Microsoft have created and put up on GitHub. So we'll go to the GitHub repository and we'll clone it down to the machine. And first of all, what we're going to do is run a PowerShell script, which is going to deploy the application into my subscription, and then we'll do a load test against that. And then we'll use that same application in a few moments in a CI/CD pipeline using GitHub Actions. So over here, I've got this page up. Again, look below for the link in the description there. This is over at Azure Samples, and this is called Node.js-app service-cosmosdb-bottleneck. So the idea of this is to have a bottleneck in it in Cosmos DB, and we'll pick that up and we'll find that during the Azure load test that we go and run against this application. But first of all, what I'm going to do is I'm going to fork this repository into my own GitHub account. So there we want to create a new fork into Matt Orford. I'll leave that repository name and we'll just create the fork there. All right, that looks good. So I'm just going to go to code here and I'm going to copy the URL because I'm going to clone this down to my local machine. So just over here in VS Code, just bring up the terminal here and I'll just do it right here. That's fine. I'll do a git clone and then paste in that URL. So it's going to clone down that fork of the repository that I made to my local machine here. We'll have a look at a few of the files and we'll go ahead and we'll do a deployment here when this completes. Okay, so let me close these JMX files that we were working with before. We don't need them anymore, and I'll get rid of the terminal just to get some more space there. So inside of this repository, the first thing that I actually want to bring your attention to is there's a file in here, a PowerShell script called deploymentscript.ps1. Now, I'm not going to go through this line by line with you. Terminals come up again there. Let me get rid of that. What this is going to do is it's effectively going to deploy an ARM template. So I'm just going to scroll down here and there's a few things. So it does some read host. So it asks you for the web app name. I think it asks for the resource group as well. But as I scroll down here, we can see that it is going to go and do AZ group create. So this is using the Azure CLI. So it'll go and create a resource group. And then down here, where are we on line 67? It is deploying the sample application. So that is doing an AZ deployment group create. And if I scroll across to the right here, what it is deploying is this file here, which is windows-webapp-template.json. And it's sending through a few parameters based on that information that we passed through from the read host prompts that came before. As I come down and have a look here, so it's then going to set a few connection strings and some app settings on that web app. And if you wanted to, I'm not going to go through this in detail, but here is the template here, windows-webapp-template.json. So that is going to go and deploy that app service and the Cosmos DB. So let me get the terminal back up there. And what I want to do is just change directory into that Node.js directory. And let's go ahead and run deployment script.ps1. We don't need any arguments on that deployment script. It's going to use read host to ask us for a few properties here as it goes. Just while that's loading up there, also do remember I did, as it says here, so it says currently logged into subscription pay as you go, which is my subscription and that's the one that I want. So I did do a connect-AZ account and an AZ login using Azure CLI before I started filming this as well. So I have done a login to Azure there already. So that subscription ID is good. And then it says enter the web app name. So for that, I'm going to call it MA Load Test. And then it says enter location. I'm going to leave the default there of East US. You might remember back at the start, I deployed all my things in East US. So that is where I'm going to leave this as well. So we can see here, that's going to go and create a resource group, MA Load Test East US-RG. And then it's going to go and deploy the ARM template, which will deploy that web app and the Cosmos DB. As it says there, this will take a few minutes, so let me go ahead and pause and we'll pick it up when that's done. Now that is actually still running there, but I just remembered that there is another file that we need to look at. So we can probably do that while that is running down the bottom there. So here in the repository, I'm just going to scroll down and they have also provided in this repository some JMeter scripts. So there's one here called sample app. And I'm just going to scroll the terminal a little bit down out of the way there. We'll just leave it there so we can see when it finishes. But this is a JMeter script that I'm going to use in this load test against this application that we're deploying here in just a few moments. And as I scroll down, there's just a couple of things that I wanted to highlight. So first of all, it is using a user-defined variable there for the domain. So we're going to enter in the name of the web app that we're deploying, and we'll pass that through with an environment variable. And then this one here is doing a GET request against a path called last timestamp, and it is using the HTTPS protocol. So that is one of the things that this JMeter script is doing, is a GET request for that URL. But as I scroll down here a little bit further, let me just keep going down to the next section. So here we've got, against that same web app URL, it is also now going to do a post to a path which is at add, and again using HTTPS. So this is an example JMeter script that is doing multiple different requests against that endpoint URL. So we had a GET at the top, and now we've got a post here. And if I scroll down a little bit further again to the next one, we can see here again against that same web app there that we're entering in, this one is also doing a GET request against a path called GET. So we've actually got 3 different APIs, if you like, in this test that will be hitting the endpoint in 3 different ways. And each of those 3 different ways will also be doing it at a different cadence as well. So it's not like we're saying, hey, spin up 1,000 virtual users and hit all of those endpoints at exactly the same time. And this is an example of a more real-world based application where you might be doing more requests over the other based on the actual, user profile of what that user would be doing on the application. So this sample app.jmx file is the one that we'll use in a load test here in a moment when that application has finished deploying. And I can see it's still running down there, so I will pause and be back with you in just a moment. And that's finished up there, and it's looking pretty good. So down the bottom here, we can see the deployment is complete, and it says open the URL maloadtest.azurewebsites.net in the browser if we wanted to open up that. But first of all, let's jump across to the portal and we'll just have a look at what's been deployed. So let me go back to home here, and we'll jump into resource groups. And that one was this one here, MA Load Test East US-RG. And then if I scroll down a little bit, we can see here we've got an app service plan, Cosmos DB. We've got the load testing service that was from before. This is the same resource group that we spun up in the demos before. And we've got the App Insights instance there as well. So if I go to this app service here, and then up here at the top right, you'll see it's got this URL here of maloadtest.azurewebsites.net. So I'm just going to copy that to my clipboard. And if I was to fire that up in a new tab here, this is just going obviously to the base URL. As we saw in that JMeter script, there was a few different paths we can go to, but this is a very simple app. All it's doing is counting the number of total visits here, and it's incrementing the time since the last visit as well. So we can see there are 2 total visits. One was the deployment script that went and deployed this thing, and the second visit there is me. So that looks like it's working okay. So let's go ahead and spin up a load test into this web app. So I'll come back down here to the Azure Load Testing service. So this is what we spun up before when we were doing the different tests before. And I'll come back into tests here. And this time we'll go and create a new test. The test name that I'll give it, I'll just call this one stress test. That's fine. We'll run it after creation. That's good. On the next page for the test plan, what we want to upload this time is that sample app. So here in that repository that we cloned down, I'll scroll down and we have got, where are we? Sample app.json. Sample app.jmx, and we'll upload that into here. The validation there looks good. So on the next page in parameters, remember when we looked at that JMX file, it was expecting an environment variable, and that was simply called web app this time. And the value needs to be that URL for the web app without the HTTPS actually. So just maloadtest.azurewebsites.net. Now we don't need anything else there. That's okay. We're not doing any secrets in this one. So next on the load, I am actually going to scale this one up to 5. And I just am doing this to really show and exaggerate, I guess, the errors that we're going to see here. So the idea of this is that there is a bottleneck built in with Cosmos DB, and I'm just going to scale that up to 5 engine instances so it's really clear as to what's happening there. I think we can leave the test criteria for now, that's fine. Under monitoring, let's add in those backend resources because they are deployed in Azure, right? So let's sort by the resource group here. And let's go and drop in Cosmos DB. We'll drop in Application Insights. We'll do the app service plan and the app service itself. I think that'll be fine for this one, and I'll apply that. We'll just use those default metrics that Microsoft are going to give us when we select those resources. I won't go and tweak any of those. And with that, we can do a review and create. Validation has passed, so let's go and create that. So that'll create the test, a new test again, and it will now go and run that test as well. So let me speed things up here in just a moment to where it starts to get interesting, and we'll have a look around and see what's happening. Okay, here we go. This is looking promising. So things are starting to kick off, and those 5 engine instances are being spun up there by Microsoft, and the test is starting to execute. We're getting some successful responses there on the right-hand side, so that's looking good. And down here, the requests per second are starting to ramp up, and we've got some virtual users here which are slowly ramping up as well on the left-hand side. And actually, we're getting some errors already. I'm not sure if I was expecting to see those already, but hey, that's fine. We'll let those kind of roll through. And you can see here that things started off pretty well with the response time. It was pretty low here for the first, the first 15 or 20 seconds. But then as the errors started to come in here, and we can see we are getting a lot of errors now, that the response time certainly shot up, somewhere between 3 and 4 seconds here at the moment. And these users here on the left-hand side are still ramping up because I scaled that up to 5 engine instances, right? So we are throwing a lot of load at this thing. The request per second on average there is looking good, and we're still getting these errors through. So I won't scroll down to the server-side metrics just yet. What I'll do is I'll just pause here. We'll let the rest of this test kind of run out and then have a look at both the client-side metrics and the server-side metrics for this particular test. And it looks like that test has finished up there. If I just scroll up, yep, looks like it's done there. We can see at the top right. And if I come down, one thing that I did want to point out actually that I didn't show before is that you'll see here there's a couple of different graphs on the response time and if you're watching on the virtual users and that kind of thing. So we can see here down the bottom that we've actually got the last timestamp and then another one called get and then another one called add. And each of these in this chart here, they have their own lines as well. And what those are the individual API calls that was being done in the JMeter script. So remember when we had a look at that JMeter script, there were those individual different calls that are being made to the endpoint. That is how you can see them here. So most of your calls might actually be successful and you might just have a problem with one of them. Maybe it's a post request or maybe it's a get request. So that is an easy way to see if your problem is across the board with all of your API calls or your requests, or if it's just a particular one. So with that, let's scroll down. We can definitely see there are a lot of errors there. I'll probably scale that up way too much. If you're playing around with it, you should actually get the errors okay if you're just run on one test engine, but I really wanted to exaggerate the errors there. And if we scroll down, what we can start to see, actually none of those metrics have actually updated there. So let me do a hard refresh here just to pull in those Azure Monitor server-side metrics from the backend resources that are hosting this application. So as I scroll down, look at that, actually we've got some statistics here at the top. So that duration was 6 minutes and 48 seconds. We can see the response time was up there at 3.46 seconds, and the error percentage was actually 16.07%. So if we scroll down, we'll see some server-side metrics here. So we can see things like the total requests into the app service. Sorry, that is into the Cosmos DB, not the app service. And this actually shows where the issue with this application is. You can see here, we've got the normalized RU consumption has shot straight up to 100% pretty early on in the testing. And as we start to correlate this, we can see some App Insights data coming through there as well. The CPU percentage on the app service did start to get up there towards the end, but it didn't quite max out. So we know that that's not a problem. The memory percentage there looks fine at 15% on the underlying app service plan. But we can see that we did get a bunch of HTTP 500 errors on the app service, and the request shot up there to about 10,000 towards the end. But if I do scroll back up, the main thing that we want to pay attention to here is this normalized RU consumption. So we can see that that did indeed shoot up to 100% pretty quickly, and that's because the Cosmos DB has an RU limit set on it, and we hit that pretty quickly with those requests, and then it just flatlined from there. So that was causing client-side issues as well as server-side issues, as we saw with all of those errors that were occurring. So this could be a real-world use case with your application. You might have developed it, created it, spun it up in some Azure resources and done some testing with, 5 or 10 or maybe even 20 users, and everything could be fine. But now it's time to really understand, where does your application start to fall over? What's the first bottleneck? How many users can you actually support with your current infrastructure, your current SKUs? Do you have autoscaling turned on? Do you need to turn it on for some of the components that you didn't think about? And this will really start to surface some of that, and it gives a beautiful view of client-side metrics and then correlating that with the server side as well. There's no real needing to come in here and look at the client-side metrics in one tool and server-side metrics in another, and trying to correlate timestamps and that kind of thing. So I think you'll find this really beneficial. And so that was what I wanted to show there with this kind of stress test against this application that's got a bottleneck in it. So the very last thing that I want to show you is using a CI/CD tool. In my case, it will be GitHub Actions, but like I said, there's an example here for Azure DevOps as well. And that is to now incorporate an Azure Load Test inside of a pipeline or a workflow inside of that CI/CD tooling. So with that, let's jump back into VS Code here. And what I want to do, we'll get rid of terminal for now. And on the left-hand side, let me close that sample app JMX as well. We do have a workflow file in GitHub. So in this repository that we've cloned down, all of the GitHub workflows sit under this .github folder. And then underneath workflows here, we have a workflow.yaml file. And a YAML file is a way of describing how you want your GitHub Actions workflow to actually go and run. So let me walk through this with you at a pretty high level. So first of all, at the top here, we just have the name for the GitHub Actions workflow that will show up in the portal when we kind of load this in. And then the next thing that's being defined down here is, when is this workflow going to run? And so by default, this is just going to run when there's any push to the main branch. We could add other triggers in there. There's a bunch you can do in GitHub Actions. That's a whole other thing that we're not going to go into right now. Down here, we've got a number of environment variables, and these are defined in the GitHub Actions workflow, and these then get used later on in the workflow. So I do actually need to change a few of these, and we'll do it now. So the Azure Web App name, mine was called MA Load Test. And an important point, if you are following along, is that this GitHub Action workflow will actually run another deployment into Azure using that ARM template. So again, if you don't name your resources the same and you've been following along with these demos, you could end up with multiple resources in Azure and therefore more cost. So just something to be aware of. The load test resource for me was called MA Load Testing 01, and the resource group was called MA Load Test East US-RG. MA Load Test East US-RG. Yep, that looks good. The rest of those environment variables, actually, we did need to change the location because we're across in East US, and East US for App Insights, and East US for the database location as well. So those are just some environment variables that get used later on in this workflow file. So if I scroll down, what we've got then is we have a job, and that is a GitHub Actions workflow job. And the name of this job is Build and Deploy, and that is going to run on a Ubuntu runner. That's one that's hosted by GitHub and provided to us when we run this. So we don't need to go and provide our own virtual machine or container to run this workflow on. GitHub will give us one where we can execute our pipeline or our workflow. And then once it's done, it'll go and destroy itself. Down here a little bit further, we then have a bunch of steps. And these are effectively the individual GitHub actions. What's it going to do when it gets started? So here underneath the steps, let me try that again. Here underneath the steps, the first one we have is a checkout action. So this is using actions/checkout at v2. So that is the name of a GitHub action that this will go and run. And all that is going to do is check out this repository that we're working in right here so that we've got all of these files on the runner. And then what it's going to do is use this, let me get rid of that again. What this is going to do is use Azure/login at v1. And that is a way to log into Azure using a service principal. And we need to go and set up a few things here in a moment for a service principal for the GitHub action to use. So down here, you can see under with, and then we've got creds, it is using secrets.azure_credentials. Now that means that we need to have a GitHub actions secret called Azure_credentials, and that needs to have a JSON payload from a service principal that we set up inside of Azure. This is effectively what allows GitHub Actions to authenticate and communicate with Azure and have certain role-based access control to go and do things inside of Azure. So we'll set that up in a moment. I'll walk you through that. No worries at all. As I scroll down here, we are then going to do an ARM template deployment, and that is going to use PowerShell here to do that. And actually, it's then going to use, it looks like the Azure CLI down here. When we have a look at the inline script, it is going to do an AZ group create. So it's going to go and create a resource group, and then it is going to go and do an AZ deployment group create. And if I scroll along here, where is it? So it is going to use that same JSON file that we just used a few moments ago when we span up this environment manually. So that is going to go and pass through some of those environment variables that we defined at the top of the file into this deployment down here. So there's a few things that I actually need to do here as well, because there was some hard-coded stuff. And I think it's mostly around the resource group name here. So we want to have the web app name, and then we need East US before the -RG there. And I think we will need that. Let me just copy the name there of the resource group. And we need it down here. Actually, we need it down in all of these ones here. So let me just replace this real quick. Again, this is just so that it doesn't go and spin up a new resource group for me and go and deploy new resources, because I do want to reuse what I've already got. Now, I think that is all I needed to change there. Everything else should actually remain the same. So if I scroll down a little bit further, let's have a look at these last few actions or these steps that are occurring. So this one here, once we've got our infrastructure, this is going to do a deployment to the Azure web app that it stood up. Now, we've already got that, but this doesn't need to know. And so this is going to use the web apps deploy task, and it is going to call the environment variable that we defined for the Azure web app name. And the package that it's going to deploy is using an environment variable as well, but it's effectively this repository here that we're working in. This is where the code is for the actual web app that it deploys. So it's going to do a web app deployment from this repository up into that Azure web app. Now, if I scroll down a little bit further, what we've got here is another job that runs. So job number one was kind of a build. So that was deploying a template into a resource group and deploying the web app into the app service that we deployed up in Azure. So now it's time to go ahead and actually do the load test in a pipeline here. And this example here has it happening under a separate job. So again, this one here needs the build and deploy to have worked okay. And it is going to run on Ubuntu-latest as well. And again, we've got a bunch of steps here. First of all, it's going to check out the repository, same as it did before. Then it's going to log into Azure, same as it did before. And what it's doing down here is it's going to go and create a resource group. And what this is doing down here is that it's actually going to create a resource group and a load testing resource as well. So this pipeline not only deploys the test application, that web app and the Cosmos DB, but it can also deploy the Azure Load Test resource itself. So if we scroll down here, it's going to do an AZ group create to spin up a new resource group. And then it is going to do an ARM deploy of, in here, there's a directory called ARM template and then template.json. And this here is going to spin up a brand new load testing resource. So you might want to modify some of these variables here so it uses the same one that we've already spun up. But for now, for me, that's okay. What we've got down here is a task now that is using Azure/load testing. I keep getting that wrong, sorry. Let me try that again. It is using Azure/load-testing at v1. Now that is a GitHub action to go and initiate a load test inside of an Azure load testing service or a resource. And there's a few important things here to pay attention to. So with some of the properties that this is going to run as. So first of all, the load test config file that it's going to use is sampleapp.yaml. Now that is different to the sampleapp.jmx that we just used a few minutes ago. This is a YAML file, and this is how you need to define the configuration for a load test when you're using it in a pipeline. I'll show you that YAML file here in just a few moments, but bear with me for now. So again, this task or this action right here is going to initiate the actual test itself. So the load test resource is what do we actually want to test? And so that is pulling that environment variable and the name of the load test resource. And again, the resource group is where that load testing resource, the Azure Load Test service itself sits. It is sitting in the load test resource group. Down here, it's then passing through some environment variables into the load test itself. So this is the same as what we did before in the user interface when we defined an environment variable. This one here is defining a name of web app, and for the value, it is passing through the environment variable from this GitHub action higher up, and then .azurewebsites.net. So it's effectively passing through the name of the web app that it deployed in an earlier stage of this GitHub action. The very last thing down the bottom here, as I scroll down, is that we have an action here to upload the artifacts, and it is going to go and upload the load test results into the GitHub workspace. So that is something pretty nice actually. When you generate the load test here, you can actually pull out the load test results and then upload that to a specific path as well. So again, just to reiterate here at a higher level, this GitHub Actions workflow has two jobs in it. The first is that it's going to go and do a build and deploy, where it's going to deploy an ARM template, which is that web app service with the Cosmos DB from this repository here, and it's going to deploy the front-end web app into the app service. And then under the load and test job, it is going to go and deploy a resource group. It'll go and deploy Azure Load Test Service, the full-blown thing, and then it will go and initiate an Azure Load Test using sampleapp.yaml and this environment variable down here. And then finally, it will upload the results to this path down here. So let's go and have a look quickly at this sampleapp.yaml file, because this one here is important. So we've got sampleapp.yaml. And actually, just before we do, in the web browser here, I do have another page open that is called Configure a Load Test in YAML. Again, links down the bottom. So this is to learn how to configure your load test in Azure Load Testing Preview by using YAML. So you use this test configuration YAML file to create and run load tests from your continuous integration and continuous delivery CI/CD workflow. So as I scroll down here, these are all of the keys that you can put into that YAML file. And of course, you might have different values depending on what it is that you want to do. So we can have things like, the name of the test, we can have the test plan, we can have the engine instances, how many do we want, do we have any configuration files that we want to pass in, so on and so forth. Failure criteria, secrets, environment variables, all of the things that we could do in the portal, you can also do here in this YAML file. And this is an example of all of those values being used. So if you wanted to come in here and have a play around, definitely check out this page and have a look at the different configuration that you're able to do. So with that, back over in VS Code, this one here is actually pretty straightforward. So it's got a version, which is just going to be called version 0.1. The test name is going to be sample app test. The test plan that it's going to run, that is where you point it to the JMeter file or the JMX file of what you actually want your load test to do. So this is going to use that same sampleapp.jmx that we just used a couple of minutes ago in the last demo, and it's got a description there, and it's only going to spin up one engine instance in this particular example. So without further ado, I know that was a lot of information there. Hopefully that is making sense. Back over in the workflow file, what I'm going to do is, because I put those environment variables in, I'm going to save that file. One thing that we need to do over in the GitHub portal first though, is when I've forked this project, I'm going to come here under the Actions tab. This is where GitHub Actions, the user interface for it is. And by default, when you fork a repository, workflows aren't turned on. I think this is to stop people potentially forking repositories where they didn't realize workflows were configured, and it can stop all these actions running if you weren't aware what you're doing. So I understand my workflows, go ahead and enable them. That is all good. Cool, looks good. So we've got the workflow there, and we can actually see the sample app deploy here as a workflow file. That hasn't got any runs yet because we haven't done any commits to main, which was the trigger for that workflow. So the other thing that we need to do before we get too excited here is we need to set up that service principal and the GitHub secret to allow GitHub to communicate with my Azure environment. So over here under settings, I'm going to come down and go into secrets and then into actions. And what we need to set up here is a new repository secret. And I've forgotten exactly what it's called. Let me just jump back over to here. I think it was just, it was Azure_credentials. So I'll copy that, and that is the secret name. Now we need to go and set up a service principal so that we get a JSON payload to actually use as the value here. So what I'll do back over in VS Code, I'm just going to bring up the terminal here and clear the screen. And I should be able to create this from here. I've got some code over here on the left that I'm just going to copy in. So I'm going to use Azure CLI to set this up. So I'm just making sure that I'm scoped to the right subscription there with AZ account set. And then the important one that I'm going to run is this one here. So this is simply running AZ AD SP create for RBAC. Now there are some newer commandlets for this as well. So by the time you watch this, maybe just check the documentation to see how you should create a service principal using the Azure CLI. I'm going to give it a name here of YouTube Load Test CI/CD. I'm going to give it the role of contributor on the subscription. And if you remember back to before when we looked at the roles for Azure Load Testing, putting it as a contributor on the subscription should also give me the Azure Load Test owner role within this load testing service as well. So I am then going to scope that to my particular subscription here and use the --SDK auth parameter, which again, I think is actually a little bit out of date, but that's what the repository here is set up for. So that's what I'm going to generate here right now. So let me go ahead and run that one. You can see there it actually says option --SDK has been deprecated. But the important part that we get back here is this JSON payload here. So this has got all of the information, and importantly, it has the client ID for the service principal that was just created and the client secret. So it's going to use this information in GitHub Actions to go and log into my Azure environment and then run all of those actions in that workflow file. So with that, just let me make sure I've got that copied. We'll jump back over into GitHub Actions here and just paste that whole JSON block straight in there as the value. That is all good. So we'll add that in as a secret. And with that, if I scroll down, we can see now we've got a repository secret called Azure_credentials. And I think we should now be pretty much good to go. So I'm going to come back over to VS Code here. And remember, because I updated the workflow file, if I do a git status here, we should see that we do have the workflow has been modified. So we need to now commit that into the repository and do a push, which will then go and trigger that GitHub action. So I'm just going to do a git add and a period to add everything in. I'll do a git commit just with 2 M's. And the message here, let's just say updated variables in workflow. And then I'm going to do a git push. So that is going to push the changes from my local machine here and the copy of that repository up into my GitHub Actions fork that I made, up into the fork of the repository that I made in my GitHub account. And it looks like I haven't actually signed in here yet. So let's do that now. I'm going to sign in using my browser because that should be pretty straightforward to do. Please complete the authentication in your browser. Okay, let's go across here. That should hopefully just log me straight in because I am already logged in. There we go. Authentication succeeded. So we can close that tab now. That looks good. We'll close out of there and go back to VS Code. And there we go. That looks good. That has now pushed the change up into GitHub for me. If I go back into the portal now and over here into the repository, if I go into actions, we should have hopefully seen, there we go. We now have a workflow run happening down here. So that commit message that I had for updated the variable in the workflow has triggered the GitHub Actions workflow to kick off 13 seconds ago, and it is queued on a build agent. So what I can do is actually go into that workflow that's now been triggered, and we'll see some information about the jobs. So you can see here, we've got first a build and deploy job where it's going to run that ARM template. It's going to deploy a resource group for us and deploy the resources. And then it's going to go across to the load test job where it's going to deploy an Azure Load Testing resource for us. And then it's going to deploy a brand new load test based off that sample app YAML file and the sample app JMeter that was configured in there. So with that, let me just pause here. I'll wait till this finishes because it will take a few minutes and we'll take a look. Now we can see here, we did actually get the green ticks, which is always a good thing. We can see down here, we've got the build and deploy job, which ran and it completed in 2 minutes and 40 seconds. And then we've got the load test job, and this is pretty interesting here. You know, that one ran and it completed in 9 minutes and 53 seconds. And that's actually something quite interesting to think about if you do want to integrate these into your CI/CD workflows and your pipelines. Because if you're going and doing your load test, chances are you are going to be running it for a pretty long period of time. You know, you're probably not just going to be doing a quick 3 or 4 minute test unless you're ramping up your users against that application really, really quickly. You might be running for 20 or 30 or 40 minutes. And you just need to think about where in your CI/CD process do you actually want to run this load test? And also, what infrastructure do you want to run it against? You probably don't want to be running this against your production environment, right? Because it means having deployed the application to production to then do the load test against. And you want to catch these issues before you get into production. And you probably don't want to do a load test against production, which could actually impact real users using your application. So maybe in your CI/CD workflow, you might spin up an ephemeral environment that you do the load testing against, and you only do it in a specific branch. Maybe you've got a branch in Git that is specifically for load testing. So when you've done your continuous integration pieces, maybe then you accept or you pull that branch into a load testing branch where it then goes and does a load test against some infrastructure that's in Azure that's not necessarily your production environment. So just a few things to think through, as well as the runtime on how long this is going to take. Because when this does do a load test in the pipeline, it'll sit there and wait until that load test is done before it comes and completes. But with that said, let's jump in specifically to the load test job and we'll take a look. So as I scroll down here, we can see we've got the login to Azure, that worked okay. We've got a create resource group and a create Azure load testing resource. Now remember, because of the names that I gave those in those environment variables, it actually reused the resource group and the same Azure load test resource that we've used throughout this whole demo. So I'm not getting stung $10 for each one of those that I spin up. But the interesting thing here is this action here for Azure load testing. And you can see here on the right-hand side that took 8 minutes and 25 seconds. Now, if we just expand that out and have a look at the log that's inside of here, as I scroll down, we can see that it says that the test run was completed. And if we want to view it in the Azure portal, which we will in a moment, it tells us exactly where to go. And it gives us some information here. We can see there were 30 virtual users in total, if we look here. And the test status is done. We can get some information right here in these log files about the client-side metrics as well. So for the add API call, for the add requests that it was doing in the JMX file, here's all the response time metrics, here's the requests per second, here's the total requests, so on and so forth. And as I scroll down here, we get that for the other client-side metrics that was ran as well. So we get some information in here, but also if I jump back across into the Azure portal, if we go into that resource group, again, this is the same one that we've used throughout this whole demo. So if you use this by default and you don't change some of those environment variables, it will go and spin up more resources. I know I've said that a few times, but I'm just trying to save you some money if you do follow along. If I scroll down here, we've got the MA load testing resource that we've used throughout this demo. So if we go into tests, we'll see all the previous tests that we've done. So the first one that we did, mattalpha.com, then we used the secret against the function app. Then a few minutes ago, we did the stress test against this application. And now here, this one at the top, sample app test, that is the one that was just kicked off a few minutes ago in the pipeline or in that workflow from GitHub Actions. So I didn't create that test here. That was all done through GitHub Actions. And that was done by using that sample app.yaml file and the sample app.jmeter file. So if we go into this test here, we'll actually see the configuration. So I could go to configure here, I could configure the test, but we can see there was one run just from a few minutes ago and it ran for 6.78 minutes. And if we go into this test, like a normal test, we'll see all of the information here. So indeed, there was an error percentage. We can see the response time was 49 milliseconds. As I scroll down, we get those client-side metrics. We can see some errors started there. And this time we didn't have any server-side metrics because we didn't define any resources in Azure to go and pull into this test. We've just got the client-side metrics here, but you've seen how that can be done in the last time that we looked at that as well. So that is it for the CI/CD workflow. Actually, with that said, there is one thing that I'll add in and I'll do a rerun and we'll have a look at it. So over here in the load test configuration, you can put in some failure criteria. So in your CI/CD pipeline and in your workflow, if you wanted it to go and fail so that you could then have other actions or steps or tasks that did something different based on a failure of a load test in a pipeline versus a success, you can put this failure criteria here. So let me go back into the workflow file, into the sample app.yaml. This is where this is defined, and I'll paste in that failure criteria. So let's say we want this to fail if, what was the response time there? I think it was about 40 milliseconds, which was pretty quick. So let's say we want this to fail if it's going to be an average response time of more than 20 milliseconds, and if the error rate is more than, we'll just say 1% there. What I can do now is I can save that sample app.yaml file, and when we rerun this now, that is going to go and update the configuration of the test to have that failure criteria there. So what I'll do down the bottom is we'll do another git status, and we should see that that sample app.yaml file has changed, which it has. We'll do a git add and a period to add that file in. We'll do a git commit with a message of updated sample app.yaml failure criteria. And then we'll do a git push, which will push those changes from my computer up into GitHub there. And there it goes, beautiful. So if I jump back across into GitHub now, and I'm just going to scroll back up into actions, because that was on the main branch still, we should have seen another workflow kick off, and we have this one here, updated sample app. And that workflow is now going to go and run those same two jobs. It's going to do a build and deploy. It'll go through the process of doing the Azure Load Test again, but this time it's going to have that failure criteria in there. So what I'll do again, I'll pause this video here. We'll jump back in when this is finished. We'll have a look here, and then we'll go and wrap things up. And again there, after 13 minutes or so, we can see this workflow has finished, but this time we indeed did get a failure here. So we can see that the load test job now has a failure. So let's dive into that. And I know that you know already what it's going to be because we put that failure criteria in there. But if we have a look at the Azure Load Testing step here inside of the workflow, as I scroll down, what you will notice is right here, we have the test criteria. And under the results, we've got one that passed and one that failed. And then down here a little bit further, we've got the actual criteria. We've got the response time that I set to that very low 20 milliseconds. The actual value here was 100, and therefore the result of that was a failure. But we can see down here that the error percentage was actually okay, and that criteria passed. So if you want to build in this criteria into your workflows to fail on a specific step, or a specific criteria rather, you can absolutely do that and then influence how the rest of your workflow or your pipeline is actually going to run. Now with that, just to finish up here on the CI/CD side of things, just quickly back in this repository, if you wanted to use Azure DevOps instead of GitHub Actions, there is actually a file in here. If I just scroll up, they do have an azure-pipelines.yaml file. And that is pretty much the same as the GitHub Actions one in terms of what it's going to do. It just obviously uses the syntax for Azure DevOps rather than GitHub Actions. So you'll still need a service connection from Azure DevOps into Azure. You'll need to come in here and update the variables and have a look through and see what each of the stages and steps within this pipeline here is going to do. But hopefully that gives a good overview of integrating a load test into pipelines or workflows into that CI/CD tooling. So let's go ahead and wrap this one up. Thank you very much for watching. I hope that has been enjoyable. I'm just looking at the time that I've been recording for, and that did go a fair bit longer than I expected. Hopefully by the time I've edited this up, that it is a fair bit shorter. But that has given you, I hope, a really good overview of the Azure Load Testing service in its current state in preview. This was recorded at the end of April in 2022. So remember, the Azure Load Test service, I kind of think of as this software as a service or SaaS or managed platform where you can run your load tests from. All you need to provide is that JMeter script file that actually defines what the test is going to do, what endpoint it's going to go and hit, and then some of the other parameters for the testing, like what are the endpoints? Do we have any secrets we need to pass through for authentication or authorization? How much load do we want? How many engines do we need? And then when you press that go button, you can just sit back and relax. You can go and watch it as it goes in real time, or you can come back later when it's finished and review the results. You'll get those client-side metrics, so that simulates from the client perspective. What was my response time? How many requests were sent? Were there any errors? That kind of thing. And if you've hooked it in, you can see the server side as well. And that is where it gets really powerful, I think. If you're using Azure and you've got your application deployed into Azure, hook it into those server-side metrics and start to get that correlation between the client side and the server side. If there's errors or anomalies, you'll be able to match them up pretty easily and start to debug and diagnose and troubleshoot where in your application stack there are bottlenecks, what needs fixing, do you need to put auto-scaling in, how many users can you support. You can provide all of this information back to the business owners and start to provide all of that value there. I really like the idea behind this service because you don't have to worry about having a virtual machine or a container or any infrastructure to run those load tests from. You don't need to worry about getting the metrics out of there, the client metrics that we spoke about. You can just use this managed service, spin it up and go for gold. So remember, check it out. Follow through with the demos if you want. Remember, there will be a small cost incurred if you follow through with what I did. It's probably going to cost me between 10 and 15 bucks for this month, I reckon. Most of that for the load test resource itself, and then some other resources that we spun up. I really hope that's been useful. Thank you for watching, and I'll see you in the next one.